So I know this is a tough decision to not go for an early lunch. So instead of just a boring talk, I prepare something different. How about a magic show? Okay, so I usually ask someone from the audience, but today we'll use a very personal for that. Who knows Kelsey Hightower? Perfect. So people should know him here. He's a very famous person in the Kubernetes world. And now let's get into his GitHub account, which is public. And we can see here his username, okay, which is Kelsey Hightower. And I'll do a trick using a script that I prepared in advance. And I also can get here his Gmail address also. So I'll paste that here. And meanwhile, while the script runs, I want to understand my audience. So who is using their SCM, source control manager, based on Git, whatever Git implementation in that? Full room. And who is using GitHub in his work? So not many, but this talk is about Git and especially about GitHub. So that's good to know that you're using Git. And if we look here, we can see that Kelsey Hightower just delivered a malicious code into my repository. Okay, here I have a Docker file, and Kelsey itself, we can see her unverified, and I'll explain that. And Kelsey itself now just delivered a malicious sending of all the environment variables into a malicious server. So how that happened is not a magic, it's a nightmare, right? And this is a nightmare. It's something interesting to think about because I believe you all heard about the shift left. So we all need to shift our developer lifecycle left into in terms of quality and testing. Instead of focusing on the product, we need to focus on the code. And in quality and testing is something we can choose. We can choose if we want to get higher velocity, so we will shift left into testing in the dev phase. But in security, we are actually enforced to shift left because the way the world goes is where we need to secure our code. Secure code became the second critical asset to secure. The first one was always and will be custom-made data, but in the world of software today, code is the second critical asset to secure. And what we need to secure, if not our code vault, the safe where we keep all our code, which is our Git repository. So my name is Gabriel, and today I'm going to talk about how you need to securely configure your Git repository. This talk is not specifically about GitHub, but I can say that GitHub by default is the least secure source control. The reason for that is a traditional reason. Git is actually distributed product. Okay, it's a product that is supposed to be used by communities, by multiple people, and supposed to have the community model to protect the product. So the community model is let's think about you live in the city, you're not afraid to go at the night at the street because, you know, if you'll have something, if you have some incident, someone will see that and then call the police or something. But if you live alone, you not go in the night at the street because you're afraid. Git is the same. Git is a distributed product, and when we take it into a single organization, to be a product in a single organization, we need to learn a new ways how to protect our Git configuration. So let's talk about some what brings me into that field, what brings me to think about we need to secure our Git configuration. So a couple of months ago, a tweet came up. I woke up in the morning and I saw that tweet. This tweet, as you can see here, got 20K likes. And this guy, Stephen Lazy, complained about 35K repos that compromised by malicious code that sent all the environment variables into malicious Russian server. And that's exactly what I show you here. And I'll explain soon how it's worked. But let's look on something even more interesting. A couple of hours later, GitHub came and say nothing happened. No code is being compromised. And that's strange, right? Because we can see in the left-hand side, we can see in the left picture that the real code is compromised. Where is all that code right now? If this is a real code, GitHub cannot just remove some code that someone entered. So what happened in this carry attack? So what is the truth about this alarm? And that's a thing that we should learn about any incident alarm we see in the internet. Sometimes it is false alarm, right? Sometimes it has nothing to do in your organization, but you need to learn. You need to look at that and see what is the newest attack that's possible in this field. And this is what actually happened in the Stephen Lacy tweet. So this is a very interesting attack. I don't think it's official. I see Josh here. He maybe can say it's official because he's my oldest guy. But anyway, the Git phishing attack go this way. So some attackers go in the internet and find some unmaintained repositories or very old repositories that not maintained anymore. Let's think about some old version of Linux. In the same way, it can also do something like phishing. It can go to, for example, if there is a repo of Kubernetes or some other tool that you may use directly from the open source, it can go and create another organization that's similar to the original organization, and then fork the popular repo into the fake organization. So let's think about if there is an organization called CNFC, it can say CNFC _IO, and people can mistakenly think this is the right repo. Then the attacker is also pushed malicious code into that repositories. And this pushing is made by spoofing, the same technique that I showed you earlier, with a way that we can actually, by default in GitHub, to deliver code, to commit code in name of other. This is exactly what the attacker does. It goes to the repo that looks like the real one or not maintained anymore and push a malicious code in name of someone else who look reliable. Okay, and then next, some innocent user who trying to use directly the tool from the source code instead of installing that from a package manager or something. I'm going to GitHub, I'm looking for the code, and then I clone it to my repositories. I run it in my repository, in my environment, and then the attacker get all the credentials to mine. So that's a very sophisticated attack. And this is what actually happened in the Stephen Lacy tweet. Some attackers, a group of attackers, cloned a lot of repos on GitHub. It wasn't 35K. GitHub search was really bad back then. It was like 1,000 of repositories that cloned into a dummy organization in GitHub and looks like spoofed by real identities that made. And then when GitHub find it, they just remove all those repo. And this is why GitHub came after and say nothing happened. But that's not true. Something happened. And this something I need to be aware for my SEM configuration. Another point of SEM today is also the build pipeline. And this is what happened in the Codecov breach maybe it was even a year ago. Codecov is a very popular library for measuring coverage on testing. And what happened in Codecov is that someone has a vulnerability, someone insert malicious code into Codecov that send, again, all the environment variable. That's the thing that attackers want today. My environment, because this is considered as the safest place to keep secret, not for a long time, for the specific runs, but this is where I want to get the most sensitive data. So people put some malicious code in Codecov that send all the credentials and environment variable to their servers. And then everyone who used Codecov, even in their, unit test environment on the build phase, sent all their credentials into the malicious server. And this is also something you can avoid if you will configure well your SEM. And now you ask yourself, okay, you're talking about, but what we need to secure. So there is a book, Aqua Security support that, and the CIS published that. There's a book with a lot of data about supply chain security, but the first 2 chapters of that book is talking about how to secure your SEM and build pipelines or CI/CD even pipelines for such kind of attacks. So let's go quickly about those 2 chapters. Let's think about the code changes. How many of you now know that all their organizations on GitHub enforced signed commits for every commit? How many of you can stand now and say, I know that all my commits are signed? If your commits are not signed anyone can get into these commits and change your history. Changing your history can lead to phishing and can also fake permission. Let's say, for example, you trust on code owners. If you are not signing your commits, nothing will have for code owners. I can fake my VP R&D identity and deliver code instead of him. We have a good strategy for code reviews. Are we protecting branches with all the requirement test and security test to make sure that all our delivery are made with proprietary tests for that? And what about repo management? We have organization and we have people who manage those repo. Are we keeping list privilege on who can create repo, who can delete repo? Are we checking that unwilling deliveries can happen? If we have public repo, we make sure that all the requirement MDs like Markdown, like security Markdown is there. And how about the contribution access? We know what happened in the code, but who can access it? We will make sure that all our SCM users are protected by MFA or they're just protected by password, which is the weakest way to protect account today. Maybe we want even, to limit our SCM access to a particular IP addresses that we are using in our organization. A lot of things to think about in contribution management, because if you're just leaving that in the default configuration, it's a dangerous configuration. And then our code is not only our code, it's also code that other people contribute and third party. We make sure that we continuously monitoring everything that happens in third party libraries, in third party tool. We make sure that all our branch protection that we already discussed about also have security check to check all the stuff. And let's move to the next phase. Today, the SCM is also responsible for build environments. Many people today using not even the CI/CD system, but GitHub Action or GitLab to do all the build itself. Even if you not talk about the deployment of the real product, the build environment is sensitive also. We make sure that all the configuration is locked, that no one can go and make changes to our build environment to change some stuff and maybe skip some tests that can be a security issue after. And how about the build workers themselves? Do you remember Kotka? If I were sure that I know all the traffic that go, the outbound traffic, the ingress traffic from my build workers, I can make sure that no one can send credential to malicious server. If I will protect my build workers in a way like a firewall that limit the addresses that my build workers can get into, I can limit attacks like what had in Kotkov, even if Kotkov is hacked. And also about the pipeline itself, how I make sure that all the integrity is there. I make sure that, do I know that there is documents? Is this, many organizations, we have pipelines, someone built that in DevOps. But this guy know what he do. But that's not the way to work. That's not a continuous way to work. That's not a way that when you need to investigate attack on your pipelines or on your build process, is not a way that you will have a right way to investigate that. But you don't need to worry, because there is also solutions. There's not only reason to afraid, there's also a bunch of tools and methodologies how to deal with your SCM configuration. So the first one is a smart tool released by Aqua Security called Chainbench. Chainbench is an automated tool that you install in your GitHub account, and that's actually checking for all the configuration, if this is the right configuration, and that's giving you, it's required a lot of privilege to run, but you can run it in some, private GitHub action and stuff like that, and can make sure that all your secure is, all your configuration and secure. And how about the build workflows? So there is half a company, half an open source organization. This is why I put it here. I try to do not put companies, but this is actually all of their products are open source, that you can assign it as part of your GitHub Actions or CI/CD infrastructure, and they are actually run all the relevant check automatically. So, for example, their most popular tool called Harden Runner. Harden Runner is actually a tool that you run as part of your GitHub action. And after one run, it lists you all the addresses, all the outbound traffic made from this worker. And then you can say, this is what I want to do. So for example, we are using that to know who is taking telemetry from our GitHub actions. And how about methodologies? So we have actually, this is a methodology we used to do at Git, which I really like and I think can help you be more secure. Why not centralize all your CI workflows in one place? In this method, you can make sure that if someone wants to change something in the pipeline, in the integrity of the pipeline, he needs to pass the approval cycle, same as your code. You can take your pipelines to be methodic in the same way you're doing as code. I'm not going too much in details because the right thing to do is what you can see here in this slide. So the next generation, in my opinion, of configuring your SCM is by using infrastructure as code. So you may already configure your cloud account as code, your cloud resources, your Kubernetes clusters, your AWS resources, whatever it is okay to start configure your code itself as code too. So there is a provider for every, I specifically use Terraform, but I believe there is also for Pulumi. There is provider for every source control manager in Terraform. So instead of using, the UI and checkboxes and stuff like that to make sure that your SCM is secure, you can have standards. You can have one repository in your organization where you configure all your resources. What is my organization? What is my repository? And what is everything? And then it's exactly happen as code. And when something is as code, you get static analysis on that. You can check that when someone tries to deliver a new resource, a new organization, a new repository, a new member, it has all the check that it needs to have. Okay, and also you can have a better approval lifecycle. So why I need to wait for my VP R&D to get into GitHub UI and trying to click on the checkboxes and choose the right configuration for me, if I can just go from a template and with this template create a new repository, and then we can make sure we have a unified model, a unified template for our repositories. So if you ask me, the best thing to make sure your SCM is secure is start using it as code. When you start, it's supposed to take some time, to put all the infrastructure and stuff like that. But then it pays that it breaks the velocity because you can create resources and manage your code very faster and also in a more secure way. So thank you again for joining me. I hope you took some stuff for tomorrow to secure in your SCM. Thank you.